Okay, so today we're going to do some derivatives and evaluate them. These are just basic derivatives, so these are just the very, very basic rules on how to deal with them. The first one we talked about is the constant multiple, or the constant rule. Basically, that means that the derivative of any constant is always going to be 0 because it never changes, and that's what we're really judging, is how much something is changing. So A here says y is 7. Well, in that case, y prime would be 0 because 7 never changes, and the derivative of any constant is 0. B, we see f of x equals 0, so we would say f prime of x equals 0. Um, don't get tripped out by the fact that the number is 0. It's a constant, it never changes, so therefore its derivative is 0. C is s of t equals -3. Well, we would say f prime, or excuse me, s prime of t equals 0. And then finally, D, this may look crazy, right? Whereas k times pi squared, and where k is a constant. So basically you have a number k, and you have a number pi squared, which we know that that's a number. We write it as, pi squared instead of 9.5 or whatever that number would be, or around 10. So right, this would just also be y prime is 0. Okay, so any constant at all is going to be 0. The derivative will be 0. Now there's the product rule, and the product rule is pretty simple. Basically, it said that you take your exponent, multiply it down, and you take 1 away from your exponent. Well, for A, you had f prime of x is going to be 3 times x to the 3 minus 1, which is going to be 3x squared. So it's that simple. Now, it gets a little more complicated, for example, B, because you have f of x equaling the cube root of x. Well, we cannot leave it like this. We've got to write this as a rational exponent, where our base is just x. And so for this, this is x to the first, but then we're cube rooting it, so we write it as x to the 1/3 power. So if we left it as x to the 1/3 power, this is how it would look, or your derivative would look. You would get, g prime of x equals 1/3 times x to the 1/3 minus 1. Now, a lot of people end up making a mistake on this part here, so make sure that you are subtracting the 1 correctly. You can go ahead and think about it as 3/3 if you want, but really it's just the number 1. So you should end up with 1/3 x to the -2/3. Now, how would that look if I wrote it with a square root sign? Well, my 1 would go in the numerator. Okay. Everything else goes in the denominator. So we get 3. The reason why that goes in the denominator, x to the negative power means that is in the denominator. So this would be x to the 2/3. So that's how that would look. But we could also write it with a root sign, and that would be x squared, the cube root of that. So that's the same thing. That's what it would look like if we were to write it as a root. And then we also have c, which is we have 1 over x squared. Well, we can't do that. We have to have it as a base of x. Okay? So in this case, kind of like what I said before, if you know what the power is, and it's in the denominator instead of the numerator, it's just x to the -2. So that's what c is going to look like. So y prime is going to be -2 times x to the -2 minus 1, which this is just going to be -2 x to the -3. Or you could rewrite this as -2 over x cubed, however which way you like. Okay, so finding the slope of a graph at a point, where we have these 3 different points, -1, 0, and 1, we need to first find our derivative. So if we were to find f prime of x, the function is x to the fourth. So this is a perfect time to use the power rule. So we're going to get 4 times x to the 4 minus 1, which is the same thing as 4x cubed. So in order to find, so for part A, to find the slope of the graph when these times are coming, we need to plug in a number into f prime. So we're going to get f prime of negative 1, and this is going to be 4 times negative 1 cubed, which is going to be 4 times negative 1, because negative 1 cubed is negative 1, which is going to be negative 4. So the slope of our graph at negative 1 is 4. So we just use our derivative there. B, we plug in 0. So we would get f prime of 0 to be 4 times 0 cubed, which is just 4 times 0, which is 0. And lastly, we want to evaluate it at 1. We do f prime of 1, and that's going to be 4 times 1 cubed, which equals 4 times 1, which just equals 4. So if you're looking to find the slope at any point, you just need to first find the derivative, and then you need to plug whatever your x value is into that derivative. For example 4, it says find an equation of the tangent line to the graph of f of x equals x squared when x equals negative 2. So first off, what we need is for the equation of a line, what you're going to have is you're going to use the point slope. Which point slope formula looks like this: y minus y1 equals m times x minus x1. So what we need is we need a point and we need a slope. Well, our slope comes from our derivative. So we need to find that first. So we're going to get f prime of x. And now the function is x squared, okay? So this is going to be 2 times x to the 2 minus 1, which is the same thing as 2x. So we've got our derivative. So now what we need is to find our slope at that point. So if we plug in negative 2 into here, so we get f prime of negative 2, it's going to be 2 times negative 2, which gives me negative 4. So that is my slope. That's very important. Now we just need to find our point, because we have everything else that we need. They tell us that x is negative 2. So how can I use the negative 2 to find out what my y1 would be? Well, if you remember from earlier, any point is just going to be x, f of x on a graph. Okay, these are coordinates. Okay, so what I need to do is I need to plug my negative 2 into f of x to get out what it would be. So in this case, you get negative 2. That's going to correspond to negative 2 squared. So that is negative 2, 4. So this is the coordinate point that this is the coordinate of when x is negative 2. So you get negative 2 and 4. So I need to use all this information together, and I will have my answer. So I go back up to the top. I'm going to get y minus my y coordinate, which is 4, equals my slope, which is 4, times x minus my x coordinate, which is negative 2. So I get y minus 4 equals 4x. This becomes a positive 2, so this becomes a positive 8, and you should be left with y equals 4x plus 12 as your overall answer. Okay, so that is Okay, sorry, I did notice that I did make a mistake here. It's my fault. Real quick, apologize. This should be a, because this is a -4, I misread that. So this needs to be negative. So that's going to change my answer a little bit. So I'm going to get y minus 4 equals -4x. This is a plus 4 times a, or a positive 2 times a -4 is going to give me a -8. And I should end up with y equals -4x minus 4. Sorry about that mistake. Everything else was fine. I just forgot my little negative over here. All right. So as we go on, so the constant multiple rule is something else we'll talk about. You just have to think, what is the coefficient? What number is out front of x? So you kind of have to just separate things. For a, you have 2 over x. Well, this is the same thing as 2 over 1 times 1 over x. Okay? So think of this 2 over 1 as separate. It's out on its own. You can leave it on its own and just do the derivative of 1 over x, and the 2 will ride its way down. It's guaranteed to work. So this is the same as 2, or excuse me, the y prime is going to be the same as 2 times the derivative of 1 over x. Okay, so the derivative of 1 over x is going to end up being, if you do the power rule, is going to be -1 over x squared. So again, if you do derivative of 1 over x, so just to show you how this works, right, this is the same thing as the derivative of x to the -1, which is -1 times x to the -1 minus 1, which gives you this up here. So the 2 is going to ride its way down. So you don't even have to consider it, just move it to the outside. So this ends up becoming -2 over x squared. And then you've got b, which you have this 4/5, or 4t squared over 5. This is the same thing, so you just figure out the numbers, right? So you got 4 over 5. Well, that stays out front. You can keep that away. And then what you're left with is t squared over 1. So all this is what's the derivative of t squared over 1? And you multiply that by 4/5 in the end. So this, the way this is going to look is that f prime of t, that's going to equal 4/5 times t squared. Or excuse me, 2t. Because if you have t squared, the derivative of that is going to be 2 times t to the 2 minus 1, which is the same thing as 2 times t. And this ends up equaling, if we have just a number times a fraction, think of the number as 2 over 1. Multiplication of fractions is very simple. This is going to end up being 8/5. You just multiply straight across numerator to numerator, and t. Okay, 6. So the sum rule is probably the easiest rule that you'll come into contact with. You just, anytime you are adding or subtracting terms, all you really have to worry about is the derivative of each individual part, because it's going to add and subtract together. So don't think of this as one big chunk. Think of it as 3 little tiny things that are put together. So for a, we just need to do the derivative of each thing individually. So x cubed, if we used our power rule, is going to become 3 times x to the 3 minus 1. And then we subtract. And we look at what's the derivative of 4x. Well, this is going to be, okay, so this is careful, 4 times x to the 1 minus 1, right? X, the x power, this is imaginary 1 here. Then we finally add derivative of a constant, which is 0. Okay? So if we simplify this, we're going to get 3x squared minus 4. because anything to the 0 power is just 1, so negative 4 times 1 is minus 4. And then we have b. So we go about this separately. So we've got g prime of x. This is kind of combining a couple of things that we've done. So this is, let me rewrite this real quick, so just so you can see what I'm talking about from our previous slide. So if we have negative x to the 4th over 2, that's the same thing as negative 1/2 times x to the 4th. Okay, so it's easier to think about moving this number out front than to think of it as a fraction all the time. So if I end up doing this power rule with this down here, I'm going to get 4 times that negative 1/2, because it stays there, times x to the 4 minus 1, and then adding derivative of 3x cubed, which is going to be 3 times 3 times x to the 3 minus 1, and then I'm going to subtract away 2 times 1, okay, to the excuse me, 2 times x to the 1 minus 1, and if we simplify this, you should get negative 2x cubed plus 9x squared minus 2. So as we're coming to one of our last examples here, the derivatives of sine and cosine, same kind of rules, right? So we know that the derivative of sine of x, this is the cosine of x, and the derivative of cosine of x is negative sine of x. So this will come up later, but anytime you take the derivative of a co-function, so like cosine, cotangent, or cosecant, you're always going to get a negative. And anytime you take the derivative of something that isn't a co-function, you get a positive one. So just a way to remember that the negative is there. So a, if we're looking for y prime, the 2 stays out. And then we think of what's the derivative of sine of x? Well, that's just cosine of x. So that's it. That's the derivative. For b, we've got the sine, so we've got 1/2 times the sine of x. Well, this is just going to be 1/2 times the derivative of sine of x, which is cosine of x. And then c, we've got, looking for y prime. So we've got two things mixed up. So remember that we can take this one at a time, since we're adding. So the derivative of x is going to be 1 times x to the 1 minus 1. Because that's the same. Remember, this is x to the first. Bring the 1 down. Do all that. And then we add the derivative of cosine, which is negative sine. So this actually is going to simplify to 1 minus sine of x. So it doesn't matter if they're x's and trig functions mixed together. Just deal with them piece by piece, and you'll do just fine.